Good morning, all of you. Today I am delivered the lecture on the S block element. That is, the topic name is elements of group 1 and 2. Already I have discussed the topic which is elements of group 15, 16, 16, 17 and 18, which is P block element, and basically it is the 11th topic, that is elements of group 1 and 2. These 1 and 2 groups are included in S block element. So there are, in periodic table there are 4 blocks: S block, P block, D block and F block. So in S block, 2 groups are included, group 1 and group 2. Let us see some basic concept related to this topic. So S block elements, which is considered 2 groups, that is group 1A, group 1 and group 2. So this group 1A, it is called as alkali metal, and this group is called as alkaline earth metal. So basically two groups are there. It is alkali metal. Group 1 is called as alkali metal and group 2 is called as alkaline earth metal. So remaining periodic table containing D block element, it is D block, it is P block and it is F block element. So in P block there is a group 15 to 18 and 3 to 12, that is 13 to 18 is P block and D block is 3 to 12. So 1 and 2 is included in S block and this is called as S block element. So it is the positions of S block element in periodic table, that is position of group 1 and 2 in periodic table. So this group contain, in group 1, let us see which elements are included in group 1: lithium, sodium, potassium, rubidium, cesium and francium. So lithium, sodium, potassium, rubidium, cesium and francium. Then beryllium, magnesium, calcium, strontium, barium and francium. So these elements are included in group 1 and group 2. So these are the important, very important elements. Alkali metals are very important as well as alkaline earth metal, in which alkali metal most important are lithium, sodium and potassium. Whereas for alkaline earth metal, beryllium, magnesium, calcium, barium is also important. It gives oxides, hydroxides form. So these important elements, they may ask the question on this topic. So I have already discussed the group 13 and 18 atomic size is increases down the group. So similarly in group 1 and 2, when we go down the group, atomic size will be increases. Atomic size and atomic radii will be increases. So same trend is follow in that group. Next, some characteristics properties of alkali metals: lowest first ionization energy and very high second ionization energy. So first ionization energy is lowest, so lowest to highest, and whereas second ionization energy is highest to lowest. Means first ionization energy is low and second ionization energy is high. So remember that this property is very important because they ask the question on this ionization energy. Then alkali metals are called as soft metal. We know the example, that is sodium. Sodium is a very soft metal which is easily available in our lab, which is used for identifications of the organic compounds. So we cut the sodium metal and use for the extract sodium, to prepare the sodium extract. So it is a sodium is a very soft metal. Then All alkali metal has metallic character. All alkali metal has metallic character. Low electronegativity means what? It has high electropositive. Low electronegativity means highly electropositive. So this is a very important property of alkali metal, highly electropositive. So electropositive means what? It acquires the positive charge. It acquires positive charge, having the tendency to lose the electron. It acts as a reducing agent, so it loses the electrons. Then basic oxides and hydroxide. They forms a basic oxide and hydroxide. Ionic bond with fixed oxidation state is a plus one. So it has plus one oxidation state. So this property is very important. Soft metal, low ionization energy and high second ionization energy. It has, they are highly electropositive, means they acquire the positive charge. Positive charge means you know that always sodium has a plus charge, potassium has a plus one charge. They you cannot see the K has a minus charge or sodium has minus charge. So it is a positive. They are electropositive elements, electropositive metal, because they have tendency to donate it electron, donates the electron or lost the electron. They lost the electron and forms the this condition, that is positivity. They are tendency to lose the, they have tendency to lose electrons, means they are positive in nature, electropositive in nature. They are highly electropositive means what? Opposite to that, there is a low electronegativity. Low electronegativity means what? Highly electropositive. And this properties increases the reducing agent. So all alkali metals are used as a reducing agent. Reducing agent. They forms the basic oxides and hydroxides. So calcium, sodium forms a hydroxide, that is sodium hydroxide, NaOH. Then oxide is NaO2. Sodium oxide, sodium hydroxide. Similarly, calcium hydroxide, calcium oxide. So these are the properties of alkali metals and alkaline earth metal. Then ionic bond with fixed oxidation state is plus one. It's all alkali metals has fixed oxidation state, that is plus one. Then it has characteristics flame or colors. So when you burn any compound, any elements in that group one, it gives the color or it gives the characteristics color to that flame. So it is a very important characteristics. Particular elements has particular color. Use the color of flame. When you burn that element, it gives the particular color to that flame. So characteristics flame color, it is very important property of alkali metal. Then weak tendency to form complex. So it has weak tendency to form complex. So remember this property. First property is very important. Lowest first ionization energy and very high second ionization energy. This I dot E means what? Ionization energy. Then these are the soft metal. Metallic characters are present in alkali metal. Then it has a low electronegativity, means these are the highly electropositive. These characters is very important. They form a basic oxides and hydroxides. So you know the basic oxide, which oxides are formed, which hydroxides are formed, which elements is reacts when sodium is reacts with OH minus to form NaOH. So Na plus and OH minus. So you know this reaction, reactions of oxide formation and hydroxide. Then oxidation state is important. All alkali metals has plus one oxidation state, whereas all alkaline earth metal has plus two oxidation state. Then it has characteristics flame color. So these 5 characteristics are very important. It has characteristics flame color means what? After burning the any alkali metal, the flame observed having the particular color for particular element. So each element has different color to that burn flame. तुम्ही जेव्हा बर्न कराल कंपाऊंड एखादा कंपाऊंड बर्न करणार आहात कॉपर फॉइलवर तेव्हा तुम्हाला एक फ्लेम टेस्ट दिसेल. सो अल्कली मेटल गिव्स द फ्लेम टेस्ट. They act as a reducing agent. So these 5 characteristics are very important. See that atomic radii. When you go down the group means what? First is lithium, then sodium, potassium, rubium, cesium, and francium. So all these groups are down the. When you go down the group, atomic size or atomic radii will be increases. See here, for lithium, atomic radii is 0.152 nanometer. For sodium, it is 0.186. It will be increases. Then 231, 244, 262, and 270. So you know, atomic size will be increases when you go down the group. So sodium has greater size than lithium, lesser than potassium. Or potassium has greater size. They ask any elements and use the correct order for atomic radii. So atomic radii, first you know the period, first you know the elements in the group. त्या ग्रुपमध्ये किती एलिमेंट्स आहेत हे तुम्हाला माहिती असले पाहिजेत आणि त्या एलिमेंट्सची नावं काय आहेत. कारण सिक्वेन्सने जर तुम्ही हा सिक्वेन्स चेंज केला तर इथला ॲटॉमिक रेडियाई पण चेंज होईल. लिथियम, सोडियम, पोटॅशियम याच सिक्वेन्सने तुम्हाला या व्हॅल्यू लक्षात ठेवायच्या आहेत. सपोज तुम्ही व्हॅल्यू नाही लक्षात ठेवल्या तरी चालतात कारण व्हॅल्यूवरती कुठलाही क्वेश्चन नाहीये. पण करेक्ट ऑर्डर ऑफ correct order of elements means rubium, cesium, francium, then potassium, sodium, lithium. So lithium has less atomic radii as compared to potassium, as compared to sodium. So you know this trend. When you go down the group, atomic radii will be increases. Ionization energy. See, the first ionization energy is, it is 590. Then it will be decreases. So first ionization energy will be decreases when you go down the group. Down the group, first ionization energy is decreases, and whereas second ionization energy is increases. So first ionization energy is decreases and second ionization energy is increases. So remember this trend. It is very important. They ask the very important question, 1 or 2 questions asked on this topic, which is related to this atomic radii as well as particularly this ionization energy. Because we know only the first ionization energy. We think that when you go down the group, atomic ionization energy will be decreases, but it will be increases. That is second ionization energy is increases. First ionization energy is decreases and second ionization energy is increases. So it is opposite to first ionization energy. Second ionization energy is opposite to first ionization energy. Decrease and increase. First will be decreases and second will be increases. When you go down the group, first ionization energy will be decreases down the group. Then electropositive or metallic character. It has high tendency to lose the electron. Hence they are electropositive ions. They form say positive ions, means sodium lost its electron Sodium lost its electron and it converted into the Na plus. Potassium lost its electron and converted into the K plus. So Na plus and K plus is formed due to the loss of electron. They lost the electron and converted into the positive ions. So all alkali metals has high tendency to lose the electron and convert it into the positive ions. Hence, it is called as highly electropositive and low electronegative. Low electronegative. Highly electropositive, low electronegative. Then metallic characteristics increases down the group. When you go down the group, metallic character will be increases. So this is characteristics flame test. Lithium has deep red color. Sodium has yellow color flame test. When you burn this alkali metal on flame, it is a burner. So burner for on flame, while burning this element, it gives characteristics flame test. So potassium gives the lilac color, rubium gives the bluish red color, and cesium gives the blue color flame. So which flame is observed for burning of cesium or burning of lithium, burning of sodium? Sodium gives the yellow color. Then lithium gives the deep red color. So remember this, which element gives the which color, that is very important. So in the last CET exam, they asked the question, after the burning of cesium, which flame color is observed? Options are deep red, yellow, bluish red, and blue. So correct option is blue. Then calcium gives the brick red, strontium gives the blood red, and barium gives the apple green color. Then they form say oxides, peroxides, and superoxide. Oxides means oxygens is reacts with water to form hydroxyl ions. These hydroxyl ions are react with alkali metal to form hydroxide. That is sodium hydroxide. When sodium is reacts with OH minus, it will form sodium hydroxide. Then superoxides. So lithium does not form peroxides or superoxide. Other elements in that group 1. So lithium is the exception in this. Lithium does not form peroxide or superoxide. Other elements gives this reaction. So these are the example of basic oxides and hydroxides. See the name of oxides: lithium oxide, sodium dioxide, potassium oxide, potassium dioxide, rubium oxide, rubium dioxide, then cesium oxide, cesium dioxide. So these are the name of oxide, means lithium, sodium, potassium, rubium, and cesium. Then hydroxide, similarly hydroxide, lithium hydroxide. The formula for lithium hydroxide is LiOH. Sodium hydroxide, potassium hydroxide, then rubium hydroxide, and cesium hydroxide. So similarly, alkaline earth metal can also form oxides and hydroxide. So this is very important. Calcium hydroxide, it is called as slake lime, means it is used for sewage treatment. It is used in sewage treatment. Then paper industry, manufacturing of the sugar industry, manufacturing of sugar. So it is calcium hydroxide has very important uses. So you know these uses of hydroxide also. Then next is a action with hydrogen. Sodium reacts with hydrogen molecules to form sodium hydride, and sodium acts as a powerful reducing agent. So these are the reducing agent. All the alkali metals are directly reacts with the hydrogen to form hydrides. So it is a one specific example. One example is given. Remaining reactions are similar to this sodium. Means if you replace the sodium by the potassium, then potassium gives the same reaction. Potassium hydride will be formed. Sodium gives the same reaction as like lithium. So lithium, sodium, potassium, all the elements are alkali metal gives this reaction. They reacts directly reacts with hydrogen gas to form sodium hydride. Sodium hydride is a solid state. Then ionic characters of these hydrides will be increases from lithium to cesium. Then ionic character will be increases from down the group. When you go down the group, ionic character will be increases. Ionization energy will be decreases. Atomic radii will be increases. So you know these basic property or basic trends when you go down the group. Then stability of hydrides will be decreases. Stability of hydride will be decreases. Then hydrides behave as a strong reducing agent and the latter increases from lithium to cesium. So sodium hydride act as a strong reducing agent than sodium because when it reacts with hydrogen, it forms double power and double characteristics of reducing agent. So sodium hydride has powerful reducing agent. It acts as a strong reducing agent. Then all the alkali metals are reacts with halogen. Action of halogens, that is all the alkali metals are reacts with halogen, means it gives the reaction with sodium reacts with chloride, Na plus reacts with when they forms a cation, positive ions. It is electropositive elements. It reacts with electronegative element to form ionic bond and formation of NaCl, that is salt. Similarly, potassium also gives this reaction. Potassium is an alkali metal. K plus will react with halogen Cl minus to form KCl. It is another example is similarly KBr, then Ki. Similarly here also NaBr and NaR. So the reactivity of halogen towards alkaline metal is increases down the group. So down the group, this reactivity of towards the halogen will be increases. Then action with the water. Alkali metals reacts with water to form hydroxides. So water gives the reaction. After the dissociation, water gives as a H plus and OH minus. Then Na plus will react with this OH minus to form hydroxide, that is NaOH. So alkali metals are reacts with water to form hydroxide and hydrogen gas is revolved. Hydrogen gas is revolved. Then lithium reacts with slowly. When you balance this reaction, there is a loss of one H2 gas. Lithium reacts slowly, but sodium others reacts violently. That is why they are kept in kerosene oil. You know this fact, sodium is always kept in kerosene because it is highly reactive element. It is a highly reactive than lithium. So it is always kept in kerosene in our lab. It is highly reactive element. All are soluble and basic strength increases down the group. All are soluble and basic strength increases down the group. So basic strength, basic characteristics of these elements will be increases when you go down the group. So here from this slide we can learn the action of halogens will be increases. Reactivity towards the halogen will be increases down the group. Then action with the water, it is also they forms a hydroxide with the down the group. Then basic strength will be increases down the group. And sodium is more reactive than lithium, hence it is kept in kerosene oil or kerosene. Characteristics, now see the characteristics properties of alkaline earth metal. So alkaline earth metal, the second group, so these are the elements in second group, group 2, that is barium, beryllium, magnesium, calcium, strontium, barium and terbium. So these are the elements which are belongs to group 2, beryllium, magnesium, calcium and strontium. See the characteristics, they are similarly to the alkali metals, that is low first ionization energy and second ionization energy. Then metallic characters, it has metallic characters. Low electronegativity means they are highly electropositive. Highly electropositive. Similarly, as the alkali metals. Then they forms a basic oxides and hydroxide. That is calcium is an element in this group 2. It forms a calcium hydroxide or calcium hydroxide twice because calcium has a +2 charge, hence it gives the CaOH twice. MgOH twice. Ionic bond with fixed oxidation state is +2. In group 1 it is +1. +1 for group 1 it is a +1. Oxidation state is +1. For group 2 it is +2. As like alkali metals, alkaline earth metal also gives the characteristics flame test, flame color, and weak tendency to form complex. So all characters are similar as like alkali metals. Alkaline earth metal and alkali metal both have similar characteristics, but element is different. When you talk about oxides and hydroxides related to element group 2, that is calcium hydroxide. But when you talk the oxides or hydroxides about the alkali metals, that is group 1, then example is sodium hydroxide. So both elements are different but properties are same. Electronegativity means electronegativity of sodium, it is related to group 1, and electronegativity of calcium, it is related to group 2. Then atomic radii. So atomic radii will be increases when you go down the group. As like alkali metals. Alkali metal मध्ये आता तुम्ही बघितलं lithium, sodium, potassium. So all alkali metals are belong to group 1. Group 1 atomic radii will be increases. Similarly for group 2 मध्ये जे काही एलिमेंट आहेत त्यांची पण atomic radius आहे ती increases when you go down the group. So beryllium has a smallest size as compared to magnesium, then calcium, then strontium, then barium. Why? Because smallest size means what? Its radius is same. Radius is small. Atomic radius is small means size is very small. Size is bigger when you radius is big. So when you go down the group, atomic radii will be increases from barium to radium. See, the first ionization energy and second ionization energy will be low. So when you compare this both ionization energy, it will be the increases. It gives the difference. That is 900 is the first ionization energy, 900, and it is a 1760. So 900 first ionization energy is low as compared to second ionization energy. When you go down the group, it will be the decreases from down the group. ग्रुप मध्ये जसं तुम्ही ग्रुप 2 मध्ये बेरिलियम, मॅग्नेशियम, कॅल्शियम, स्ट्रोनियम and barium, down the group it will be the decreases. So ionization energy, this IE stand for ionization energy decreases as the group is discanded. Ionization energy of group 2 is generally higher than group 1. So group as compared to group 2, the group 1 ionization energy is higher. So it is a group 2 ionization energy is high as compared to group 1. Hydration enthalpy. So hydration enthalpy means what? It forms a hydration reaction, that is addition of water with the alkali metals and alkaline earth metal. Tendency to react with water or hydration. So hydration means addition of water molecule with the alkaline metal and alkali metals. Then it forms a hydride compounds or hydrated molecules. So it is called as hydration enthalpy. So when you go down the group, hydration enthalpy will be decreases. So remember these characteristics: decreases, hydration enthalpy is decreases from down the group. For group 2, hydration enthalpy is higher than group 1. So group 2 ची जी hydration enthalpy आहे ती group as compared to group 1 it will be higher. As the ions get larger, the charge density of the ions will be decreases and the electrostatic attractions between these ions and waters molecules get smaller. So atomic radii will be increases from down the group. डाउन द ग्रुप काय होईल, जो ग्रुप आहे त्याच्यामध्ये जेवढे एलिमेंट्स आहेत त्याची साइज इन्क्रीज होईल. When molecule is a bigger size, it do not reacts with water molecule easily. Hence, this hydration enthalpy or tendency to react with water, it will be decreases from down the group. So, what is the reason behind this decreasing hydration enthalpy in down the group? The reason is the size of atom will be increases or atomic radii will be increases. From down the group, atomic radii will be increases. So atomic radii will be increases. Radii will be increases. Means size increases from down the group. Group मध्ये जसे जसे तुम्ही याल तसं atomic radii increase होईल, radius increase झाल्यामुळे size increase होईल आणि त्यामुळे जी वॉटर सोबत रिएक्ट होण्याची टेंडन्सी आहे ती कमी होत जाईल. सो व्हेन यू गो डाउन द ग्रुप, atomic radius is increases, size will be more, hence it will be tendency to react with water, it is decreases. So this is a reason for hydration enthalpy is a decreases from down the group. Then it forms a group 2, that is barium, magnesium, calcium, strontium, barium. It forms a oxides and hydroxides when it reacts with oxygen molecule and OH minus molecule, that is hydroxide. It forms a hydroxide. barium oxide, magnesium oxide, calcium oxide, that is CaO, strontium oxide, barium oxide. Then hydroxide means what? When molecules is reacts, when metal is reacts with, any metal is reacts with OH minus to form MOH. That is, metal hydroxide is formed by reacting with the OH minus molecules. So barium OH twice, calcium OH twice, that is calcium hydroxide. It is called as slake water or slake lime, that is lime water, and it is used as a use in sewage treatment. So uses of this hydroxides is very important according to CT point of view. See the uses of this hydroxide also as well as oxide. So hydroxides, that is group 2 hydroxide, beryllium OH2, MgOH twice, CaOH twice, CaOH twice, strontium OH twice, and barium OH twice. Solubility will be increases from amphoteric to basic. Amphoteric means what? Amphoteric characteristics means it has both characteristics. It will show acidic character as well as basic character. It will show amphoteric means both characteristics, acidic character as well as basic. So these are called as amphoteric solvent, amphoteric hydroxide. So PaOH twice, beryllium hydroxide is a amphoteric solvent. Amphoteric hydroxide means what? It has both characteristics, acid as well as base. So hence it is called as amphoteric hydroxide. So solubility is increases from amphoteric to basic. Amphoteric to basic, and base strength will be increases. Then variation in the melting point. So melting point, when you go down the group, melting point will be decreases. Remember this point because they ask the question. Melting point is decreases when you go down the group due to the ionic radius. Metallic bonds depends on ionic radius. So bigger size, higher the melting point. Smaller the size, lesser is a melting point. Number of electrons contributed to the electron C per atom. Then when there is a contribution of d orbital, melting point will be increases. So d orbitals is the contribution असेल तर melting point increase होऊ शकतो. Decrease कधी असेल, atomic size smaller, melting point will be decreases. Atomic size larger, melting point is increases. Also melting point is depends upon ionic radius, means what? Atomic size. These are related concept. Ionic radius and atomic size, these are related concept. How it is? Ionic radius is smaller, then atomic size will be automatically smaller. When any compounds having the three orbitals, and one compounds having the 4 orbital, then which is atomic size is bigger? So 4 orbitals having the bigger atomic size. So atomic radius, ionic radii and atomic radius. Then number of electrons contributed to the electron C per atom, and crystal lattice structure. It is FCC, BCC, which already know in solid state chemistry, what is crystal lattice structure. So FCC, face centered cubic crystal structure. So you know about this crystal lattice structure, which is included in solid state. So exceptions, high melting point of calcium is due to the contribution of d orbital participation of metallic bonding. So this is exception. Remember this exception. Melting point is decreases from down the group. Down the group, melting point will be decreases. But the exception case is calcium. Calcium has the higher melting point because of contribution of d orbital. When d orbital is contributed in the bonding, metallic bonding, then there is a high the melting point. So it is exception case. Remember that calcium has melting point is higher due to the contribution of d orbital participation in metallic bonding. Then reactions with oxygen. So when all these alkali metals and alkaline metals are reacts with oxygen, they forms oxides and peroxide linkage. Peroxide linkage means oxygen dash oxygen. So this is called as peroxide linkage, and it is oxide. When it reacts with only oxygen, O2 minus, it gives the oxide. And when it reacts with peroxide to form peroxy linkage in that metals. Characteristics flame color, as like alkali metal, alkaline earth metal also gives the characteristics flame color. So calcium is burns with the HCl. Calcium and mixture of HCl will burn with this flame. It gives brick red flame. Strontium gives the blood red flame, and barium gives the apple green flame. So color, remember this color for calcium, it is brick red. CBr. CBr means calcium brick red. Strontium blood red, and barium apple green. So when it reacts with elements, elements are reacts with HCl and it burn on flame, it gives the characteristics flame color. So they ask the question on when following compounds is reacts with flame or it burn on flame, it gives which color flame. So options, you know the options, and correct options will be for particular element there is a particular flame color. Then reactions with water. Alkaline earth metal also gives the reaction with water. Similarly for the सोडियम और अल्कली मेटल्स. आता आपण अल्कली मेटल मध्ये सोडियमचं एक्झाम्पल घेतलं तर सोडियम रिएक्ट्स विथ OH मायनस Na plus reacts with OH minus to form NaOH, or loss of hydrogen gas. There is a loss of hydrogen gas. So this similarly it is called as hydration reactions, and there is a loss of OH minus and one half H2 gas. OH minus and half H2 means OH minus plus H plus. So energetic versus kinetic factors. Lithium at 3.505 volt reacts with, gives the hydration reactions with and forms a lithium hydroxide. Sodium hydroxide will form at minus 271 volt. So these are the temperature or energy requirement for the hydration reaction. Reaction with water means what? It is a hydration reaction. Then action of hydrogen with an action of halogen. Action of hydrogen means what? Calcium is reacts with hydrogen molecule to form calcium hydride. Similarly, action of halogen. Barium is reacts with Cl minus to form beryllium chloride. So barium chlorides, barium is reacts with chloride molecule to form barium beryllium chloride, BeCl2, and calcium hydride. Similarly, this sodium also gives the similar reaction. Na is reacts with H2 to form NaH2. Then reactivity of hydrides. They all readily react with water to give the metal hydroxides and hydrogen due to the strong basic properties of hydride ions. Then hydride ions are also good reducing agent. So all this LiAlH4, that is hydride, it is a reducing agent. Lithium aluminium hydride, sodium borohydride, when it combined with the alkali earth metal or alkali metals, these are the alkali metal, lithium and sodium. So it will come, and hydride is reacts with alkali metals, their reducing property will be increases. So hydride ions are also good reducing agent, and only alkali metals are also reducing agent. Means sodium act as a reducing agent. It will combine with hydride, that is sodium borohydride, lithium aluminium hydride. These are the examples of reducing agent. Remember this reducing agent, lithium aluminium hydride and sodium borohydride. To reduce carbonyl group, C double bond O group is reduced, ketone group is reduced. Thermal stability of the carbonates. So stability of thermal, they ask the question, which is the stable carbonate? How the carbonates are formed? When alkali metals and alkaline earth metals are reacts with CO3 minus, then there is a formation of carbonates. So which carbonate is very stable? So they form, say, and stability of carbonate is depends upon this thermal stability of carbonate will be depends upon temperature. So higher the temperature, lesser is the stability, and lower the temperature, higher will be stability. So temperature is the lowest at 100 degrees Celsius. BeCO3 is a stable. Means what? Higher, lower the temperature, higher will be the stability. Means among all these BeCO3, MgCO3, CaCO3, SrCO3 and BaCO3, which is stable, lesser the temperature, higher will be the stability. So this is important concept in thermal stability. How you can define the thermal stability? Lower the temperature, higher will be the stability. So BeCO3 is a, when they ask the question, that is, which of the following is a more stable carbonate? Lower is the temperature, higher will be the stability. And higher is the temperature, lesser will be the stability. So BaCO3 is a less stable at 1360 degrees Celsius temperature. These are the group 2 elements, not group 1. Group 1 are the, all other groups are stable at lesser than 800 degrees Celsius, and only Li2 is stable at 700 degrees Celsius. So this is group 2. Then carbonates and hydroxides of group 1 metals are as whole more stable than those of group 2. So group 1 चे जे carbonates आहेत ते more stable आहेत as compared to group 2. Thermal stability is increases from discarding the group. Lithium often follow the pattern of group 2 rather than group 1. So it is an exceptional case. Lithium obtain the pattern of group 2, which belongs to group 1. Lithium is belongs to group 1 element, but it forms the follow the pattern of group 2. Then this is an example of diagonal relationship. You know the diagonal relationship. Diagonal relationship means what? Though lithium is belongs to group 1 element, but it follows the pattern for group 2 for related to the thermal stability. So explanation of thermal stability, charge of the ions, size of ions. So charge increases, thermal stability will be increases, size of ions, atomic radius. So charge compounds are more stable if the charge is increases. Compounds and charge and size is decreases. साईज कमी असली पाहिजे तेव्हा कंपाऊंड जास्त स्टेबल असेल आणि चार्ज इन्क्रीज असला पाहिजे. +2 +1 +3. So +3 is more stable than +1. So charge increases and size decreases. This is a trend for more stable compound. Stability is increases when charge is increases and size is decreases. For the compound with large polarizable anions, thermal stability is affected by the polarizing power of cations. So decreasing polarizing power, increasing the stability. Polarizing power is decreases, there is a stability will be increases. So remember this. Decreasing polarizing power, increasing stability. Relative solubility of group 2 hydroxides. So stability of group 2 hydroxide, that is 0.020 into 10 raised to minus 3. Solubility of hydroxides is increases when you go down the group. So more solubility, more is the solubility when you go down the group. Solubility is given mole per 100 gram of water. So barium hydroxides is more stable than calcium hydroxide or magnesium hydroxide, because when you go down the group, solubility will be increases. Ionization energy will be decreases. Then solubility of group 2 to form the sulfate. जसं आता तुम्ही या स्लाइड मध्ये हायड्रॉक्साइड्स बघितलेत तसं solubility with the sulfate. It is also property of group 2 elements when it reacts with the sulfide ions, sulfate ions, SO4 minus. So Mg plus 2 reacts with SO4 2 minus. How this sulfate ions are formed? Mg plus 2 reacts with SO4 2 minus to form MgSO4. So this plus 2 and minus 2 charge will be balanced and it forms a group 2. It is also increases when you up the, it is not down the group, when you go from up the group, the size of solubility of the group 2 sulfate, it will be the increases. मग असे हायड्रॉक्साइड्स होते ज्या हायड्रॉक्साइड मध्ये काय होईल, when you go down the group, solubility of that hydroxide will be increases. But when there is a related to the solubility is related to the sulfate. Sulfate means what? इकडे हायड्रॉक्साइड आहे MgOH twice, त्याच्याऐवजी इथं आहे MgSO4. MgSO4, calcium SO4, calcium sulfate, strontium sulfate, barium sulfate. So when you go down the group, up the group, this solubility of group 2 sulfate is increases. Means BaSO4 has magnesium sulfate has more solubility than BaSO4. मगाशी बघितलं तर बेरिलियम हायड्रॉक्साइडची more solubility होती. आता बेरियम magnesium sulfate has more solubility than barium sulfate. because when you go up the group, solubility of sulfate ions will be increased. Then group 1 compounds are more soluble than group 2 because metal ions have the smaller charges and larger size. So delta H, that is change in delta H of solution, enthalpy of that solution is equal to minus delta H of lattice plus delta H of hydration. Hydration means tendency to react with water. Addition of water, that is called as hydration. So lattice size is smaller and delta H of solution is more exothermic. Exothermic means it gives the heat after the reaction. So for group 1 element, solubility will be more because of its smaller size. Lattice size is smaller, hence it has negative sign because smaller the size, hydration energy will be increases and there is a exothermic is reaction. Exothermic reaction means what? Two types of reaction, exothermic and endothermic. When energy is released, it is exothermic. And when energy is absorbed, that is endothermic. Exo and endo. So exothermic means when energy is released in air, that is exothermic reaction. So this is about elements of group 1 and group 2. So see the elements of, remember these elements, that is name of elements, lithium, sodium, potassium, rubium, cesium, francium, that is group 1 element and group 2 element. बेसिक प्रॉपर्टीज तुम्हाला ह्याच्या लक्षात ठेवायच्या ज्यामध्ये atomic size असेल, ionization energy आणि melting point. Related to melting point, also the electropositivity is very important. When you solve the CET questions, then you know that which are the important properties. So basically these are the very important properties: ionization energy, atomic size, electronegativity and characteristics flame color. So flame color is very important. Let us solve the some CET question which are asked in previous exam. First is, which of the compound is known as slate climb? So you know the uses of oxide or hydroxide or sulfate ion, then you can easily find the answer. Slake lime means what? It is a royal lime water. It is used in sewage treatment. Royal lime water. It is used for whitewashing. Sugar industry and manufacturing of the sugar industry, then paper industry, and very important use is sewage water. Treatment of sewage water. So treatment of sewage water. So the answer of this question is, which of the following is known as slake lime? That is calcium hydroxide is the correct answer. So you know the uses of this hydroxide, then you can give the answer. So it is a theoretical based question. So these all uses of slake lime or royal lime water. Then which of the ions have maximum hydration energy? So hydration energy means what? Tendency, hydration energy, that is hydration enthalpy. Hydration energy. So hydration energy, when you know the property, basic properties, when you go down the group, hydration energy will be increases. डाउन द ग्रुप ह्याच्यामध्ये कोण आहेत तर बेरियम इज अ डाउन द ग्रुप. So hydration energy has a maximum. And beryllium has smaller the atomic size and higher the charge. So smaller the atomic size and higher the charge, and hence it is easily reacts with water molecule. वॉटर मॉलिक्यूल सोबत रिॲक्ट होण्यासाठी काय प्रॉपर्टी असली पाहिजे? स्मॉलर साइज ऑफ मॉलिक्यूल अँड हायर द चार्ज. हाय चार्ज. सो स्मॉलर साइज, चार्ज तर सगळीकडे सेम आहे. साइज तुम्ही बघा, ॲटॉमिक साइज विल बी इनक्रीजेस and high polarizing power can attract the several water molecules. Thus beryllium has highest maximum hydration energy as compared to strontium, calcium and magnesium. So the reason of this, because beryllium has a smaller size of molecule and it has higher charge. Next question is, as compared to sodium and sodium has, which is the correct statement? So कोणाला सोडियम पेक्षा potassium and sodium has lower melting point, higher ionization potential. Options are lower electronegativity and larger atomic radius. So higher ionization potential, sodium has higher ionization potential because sodium has, other statements are correct, other statements are incorrect. Only one statement is correct because sodium has 3 orbitals whereas potassium has 4 orbitals. Sodium has 3 orbitals and potassium has 4 orbitals. So sodium reacts, it is K plus, Na plus and K plus. So sodium gives the 3 orbitals and hence its tendency to attract the inner shell, outer shell orbital and nucleus, attraction of this is very close. Hence its ionization potential is very high as compared to potassium. So this is the main reason. Here distance is more and here distance is less. And this is that's why higher ionization potential is for the sodium is high as compared to potassium because sodium has 3 orbitals and potassium has 4 orbitals. So that's why sodium has higher the ionization potential. So this is the correct option. Then next question is, which one is the most stable carbonate? So तुम्ही मगाशी बघितलंय कार्बोनेटची स्टॅबिलिटी. So let us see the last previous slide. Stability of carbonate. Then we can find the answer. Stability of carbonate. So stability of carbonate, which is most stable in group 2. Group 1 चा आपण इथे नाही बघणार आहोत कारण हा जो क्वेश्चन आहे तो ग्रुप 2 आहे की ग्रुप 1 आहे बघा. बेरिलियम, बेरियम, मॅग्नेशियम, कॅल्शियम अँड बेरिलियम. सो इट इज अ ग्रुप 2 एलिमेंट. ग्रुप 2 चा जो कॅल्शियम कार्बोनेट शी रिलेटेड जी थर्मल स्टॅबिलिटी आहे, so that gives the answer. Higher the temperature, lesser will be the stability, and lower the temperature, higher will be the stability. Lower the temperature, higher will be the stability. So which has lower temperature? So it has low temperature, so it gives the thermal stability. See, all among this carbonate which has a low temperature, beryllium has low temperature, BeCO3, hence its thermal stability is more. So या क्वेश्चनचा आन्सर काय येईल? BeCO3. BeCO3 is the correct answer because at low temperature stability is more. BeCO3 is reacts at 100 degree Celsius. So correct answer is BeCO3. Next is this is a completely theoretical question, that is, what is the molecular formula of POP? POP means what? Plaster of Paris. So plaster of Paris का formula है CaSO4 and half H2O. Calcium sulfate half H2O. It is a formula for plaster of Paris. Then which oxide is amphoteric oxide? Amphoteric means what? What is amphoteric? I have already tell amphoteric oxide. Amphoteric means give me the answer. What is amphoteric? Amphoteric means it has both properties, that is acidic characteristics and basic characteristics. Hence it is called as amphoteric solvent. Amphoteric oxide means it has both characteristics, and that is acidic and basic. So here answer is barium oxides is a amphoteric solvent. Amphoteric means both characteristics. It has both characteristics. Next, the tendency to lose their valence electrons easily by alkali metals makes them tendency to lose its electron. So alkali metal means such as sodium, which is lost the electrons and it forms Na plus. Then potassium also lost the electrons and converted into the K plus. So Na plus, K plus, they are electropositive elements. Electropositive means electron deficient. These are not electron rich. Electron deficient means they have lost the electron. Due to the loss of electron, they are electropositive in nature. They are electron deficient. Now these electron deficient compounds are called as strong reducing agent. Why? Because now these have tendency to attract the electrons from another elements, so they undergo oxidation and act as a self-reducing agent. So act as a reducing agent and undergo oxidation. Oxidation means oxidation is a loss of electron. So here loss of electron is take place and formation of positive ions. So it acts as a reducing agent, but process is oxidation. Oxidation is a process. Oxidation means loss of electron and gain of electron, that is reduction. Here oxidation is process, but agent is reducing agent because they are act as a electron deficient species. Hence, these are the strong reducing agent. Strong reducing agent. So the tendency to lose their valence electron easily by alkali metals makes them strong reducing agent. आफ्टर द फॉर्मेशन ऑफ, आता ह्याची जी रिएक्शन हा ट्रिकी क्वेश्चन आहे ज्यामध्ये तुम्हाला असं वाटू शकते की इलेक्ट्रॉन लॉस होतोय म्हणजेच ऑक्सिडायझिंग एजंट, बट लॉस ऑफ इलेक्ट्रॉन you can word remember the word that is oil rig. Means what? Oil rig means oil rig means oxidation is a loss of electron, whereas reduction is a gain of electron. So ह्या डेफिनेशन इथं का चेक करायचंय तर त्यांनी जे सेंटेन्स दिलंय, द टेंडन्सी टू लॉस देअर बॅलन्स इलेक्ट्रॉन, टेंडन्सी टू लॉस देअर बॅलन्स इलेक्ट्रॉन, sodium loss its electron loss, then it forms a one electron is lost, there is a one deficient characteristic, one deficient electron deficient species is formed. So sodium, potassium also lost their electron, converted into the K plus. So Na plus is the electron deficient species and it forms positive ions, which is electron deficient species can attract the electron and undergo this reaction is called as oxidation because it slots the electron, but the form species it's act as a reducing agent. So then या species बद्दल विचारले what make forms, they forms a strong reducing agent. So this is a answer. Strong reducing agent is the correct answer. Then find the incorrect trend for alkaline earth metal. So atomic size, when you go down the group, atomic size will be increases. So as it is given, barium, beryllium, magnesium, calcium, strontium, size increases when you go down the group. Then second ionization energy. So second ionization energy is decreases from down the group. So it's not like that. It is the incorrect state. Next option, let us see the next option, that is hydration energy. Hydration energy is a decreases from down the group. Size will be lower, hydration enthalpy will be more. Size less असेल तर hydration enthalpy more असेल. Then density will be also increases from down the group. So this is incorrect. Why? Because when you go down the group, second ionization energy will be increases. So this is a correct order and it is a incorrect order. So correct option is for this question because they asked the incorrect order, incorrect trend, that is second ionization energy. That is B. B is the correct answer. Why? Because ionization energy is increases from the down the group. Then which of the following metal is not alkali metal? So you can find the answer easily when you know the group element. एका ग्रुप मधले जर तुम्हाला एलिमेंट माहित असतील तर तुम्ही या क्वेश्चनचा आन्सर देऊ शकता. Magnesium, rubidium, sodium and cesium. So you can find this answer. Which of the following is not an alkali metal? So remember this alkali metal. These are called as alkali metal and it is a alkaline earth metal. So one is there which is not alkali metal. Check that. First one is Cl. Cs means cesium, which is alkali metal or not? Yes, Cs is alkali metal. Then sodium. Sodium is always alkali metal. That is second element in our group 1. So it is alkali metal. Then rubidium. See the option rubidium. So Rb is there. That is fourth element. So it is also alkali metal. Now correct answer is magnesium. Magnesium is a not alkali metal. It is a alkaline earth metal. So magnesium is called as alkaline earth metal. It is not alkali metal. Alkaline earth metal. Then the melting point of alkali metal is decreases or it is low. For the all alkali metals has a low melting points because of they are soft nature. Soft nature, their bonding, variation, ionic size of metal, then d orbital contribution. Only exception is a calcium. Calcium has a high melting point. So remember this question, calcium has a high melting point due to the contribution of d orbital, whereas other elements, alkali metal as well as alkaline earth metal, has a low melting point. So the correct answer is melting point of alkali metal is low. So calcium has a high melting point because it is a contribution of the d orbital in the metallic bonding. Then alkali metals are strongly electroneutral, electropositive, electronegative and non-metallic. See the example, well-known example, alkali metal means sodium. So sodium lost the electron, it forms a Na plus. Na plus having the positive charge means it is electron rich or electron deficient, it is electron deficient. So electron deficient means it has characteristics to attract the electron towards itself. How it is formed? When sodium lost the electrons. So it is an electropositive element, highly electropositive. Highly electronegative is a oxygen. Low electronegative. Suppose इथं strong च्या ऐवजी लो असेल किंवा हाय असेल तर इलेक्ट्रोपॉझिटिव्ह येईल, पण लो असेल तर इलेक्ट्रोनिगेटिव्ह येईल. सो ऑक्सिजन इज अ मोर इलेक्ट्रोनिगेटिव्ह, second electronegative element in the periodic table. Electropositivity means positive ions are formed which are electron deficient. And electronegativity means what? Electronegative ions are formed by accept the electron. Donation of electron, positive ions form. Donation of electron, when any species, any atom, donation of electrons or donate electron, then there is a formation of positive species. Positive species means electron deficient. डिफिशियंट असेल तरच फक्त इलेक्ट्रॉन डिफिशियंट स्पेसिस असेल तर चार्ज पॉझिटिव्ह असेल. ऍक्सेप्टन्स ऑफ, ह्याच्या ऑपोजिट काय आहे? ऍक्सेप्टन्स ऑफ इलेक्ट्रॉन. सो एनी स्पेसिस विच इज इलेक्ट्रोपॉझिटिव्ह असेल तर तुम्हाला ही रिएक्शन मिळेल. इलेक्ट्रोपॉझिटिव्ह मीन्स which is donates its electron and converted into the electron deficient species, whereas electronegative, या दोन्ही कन्सेप्ट तुम्हाला माहिती पाहिजे. पहिली आहे इलेक्ट्रोपॉझिटिव्ह. हु इज इलेक्ट्रोपॉझिटिव्ह? which donate the electron and converted into the positive ions and formation of electron deficient species. Whereas what is electronegativity? Electronegativity means what? It's accept the electron and forms a negative species, negative charge species, which is electron rich. So electron rich species असेल तर तुम्ही त्याला इलेक्ट्रोनिगेटिव्ह आणि इलेक्ट्रोपॉझिटिव्ह पॉझिटिव्ह चार्जेस फॉर्म. Electron deficient means electropositive. Electron rich means it is a product of electronegativity characteristics. Oxygen is an electronegative, sodium is an electropositive element. Then alkaline earth metals shows +1 oxidation state and their atomic volume is increases when you down the group. Atomic volume विचारलंय. हे एक्स्ट्राचं सेंटेन्स आहे ज्यामध्ये अल्कलाइन अर्थ मेटल, here there is only one correction, it is alkali metals, not alkaline earth metal. Alkali metals has +1 oxidation state and their atomic volume will be increases. So when you go down the group for alkali metal as well as alkaline earth metal, it gives atomic size will be, so when you go down the group atomic size will be increases from the down the group. So atomic radii तुम्ही जर बघितली 0.5, 152, 186, 231, 244 and last is 270. So it is increases from down the group. Lithium to francium, size of atom will be increases from down the group. So याचा आन्सर काय आहे? atomic volume म्हणजेच atomic size. So atomic size will be increases from down the group. Then flame color of cesium is in the flame color. So each element gives the characteristics flame color. So you know this flame color. Flame color जर तुम्हाला हे माहिती असतील तर तुम्ही ह्याचा आन्सर देऊ शकता. Lithium gives the deep red flame color. Sodium gives the yellow color. Potassium gives the lilac color. Rubidium gives the bluish red color. And cesium gives the blue color flame. So the correct answer is blue because the flame of cesium is the blue in color. Then next, which of the following is true regarding the reactivity order of alkali metal towards the hydrogen? So it is, this question is related to the reactivity of alkali metals related to hydrogen molecules. So it forms a hydride. Hydrides are formed. So when you go down the group, the reactivity towards the hydrogen is increases, means what? It forms a hydride ions. Lithium is reacts with H2 to forms lithium hydride. Sodium is reacts with H2 to form sodium hydride. So it is a hydride formation reaction. When you go down the group, it is increases. So down the group ऑप्शन त्यांनी ऑलरेडी दिलेला आहे, ज्यामध्ये lithium, sodium, potassium, rubium and cesium. So this is a correct order of reactivity towards the hydrogen. Reactivity of hydrogen. Similarly, you learn the reactivity of halogen. It will be also increases from you go down the group. So down the group, जसं तुम्ही जाल तसं तुम्हाला reactivity towards hydrogen, halogen, then enthalpy of hydration enthalpy means reactivity towards the वॉटर, रिएक्शन विथ द वॉटर. सो हायड्रोजन सोबत रिॲक्ट झाल्यानंतर आपल्याला हायड्राइड फॉर्मेशन मिळेल. लिथियम हायड्राइड, सोडियम हायड्राइड. सो दिस ऍक्ट ॲज अ स्ट्रॉंग रिड्युसिंग एजंट. This hydride also strong reducing agent. The correct answer is, this is the correct order of reactivity towards hydrogen. Okay, you have any doubt, you can ask me or comment me on that WhatsApp group. Next lecture will be start at 2:30 p.m.